Today's lesson is over solving multi-step inequalities. The first step is to solve for the variable. Y'all, that is when we have to ask those questions. Can you distribute on the left? Can you distribute on the right? Can you combine like terms on the left? Can you combine like terms on the right? Then at that point, you should have a two-step equation or inequality. Then you add or subtract and multiply or divide. It's that very last step that you have to pay attention to if you're dividing or multiplying by a negative. Does that make sense?
Yes.
Okay. So then what you're going to do is you're going to graph it on the inequality on a number line. And then we have check both sides of the inequality to verify it's true. We're actually going to do that only to one of our examples so I can explain to you why it looks an inequality is the way it is, okay? So here we go. Let's do our first example. If you're taking notes at home, just add it to the bottom like this. All right, here we go. Example 1. First two examples, and then number 1. All right, 8 is greater than 3x minus 7. So I'm going to rewrite this. 8 is greater than, have y'all noticed how much I use whiteout? 3x minus 7. All right, so I'm going to ask the questions real quick. Can I distribute on the left?
No.
Can I distribute on the right?
No.
Can I combine like terms on the left?
No.
Can I combine like terms on the right?
No.
So I should have what type of an inequality?
Two-step.
A two-step inequality, do I?
Yes.
Yes. So now what do we do when you get to a two-step inequality?
Plus the 7.
You add or subtract, and on this one we're adding 7 to both sides. So 8 plus 7 is? 15. Greater than 3x. This cancels out.
Divide by 3.
Divide by 3. Now, do I flip my sign?
Yes. No.
No, because I'm dividing by a positive. Okay? So 15 divided by 3 is? 5 is greater than x. Now, I like to flip it. Now, we're not going to flip just the sign. We're flipping the entire inequality, right? Because we want our variable on the left. So we're going to say x, and I have my 5. This is pointing towards the x, so I have to make sure it points towards the x here. So that's your answer. Now, how do we graph it? Remember, when you're graphing an inequality, I just want a 0. Whoopsie. A 0 in the number. Okay? 0 in the number. Okay. Closed circle or open circle?
Open.
Open circle. On what number? 5. Do I graph to the right or to the left? To the left. All right. Good job. Okay. So let's look at number 2. I'm actually going to start number 2 on a new paper so that I can show you all my check step. All right. Number 2, and go ahead and have out your calculators because you're going to need it for a few of this. Negative 0.6, open parentheses, x minus 5 is less than or equal to 15. Okay? That's the problem. Negative 0.6, open parentheses, x minus 5 is less than or equal to 15. Okay? What is the first thing I am going to have to do?
Multiply negative 0.6 by x and negative 5.
Okay, and that is called?
Distribute.
Distribute. All right, here we go. So we're going to distribute to each of these. Okay, so what is negative 0.6 times x?
Negative 0.6x.
Negative 0.6x. Okay, what's negative 0.6 times negative 5?
3.
A positive 3. Okay, is less than or equal to 15. All right. Can I distribute on the right?
No.
Can I combine like terms on the left?
No.
Can I combine like terms on the right?
No.
So now what do I do? Or what do I have?
Two-step.
I have a two-step inequality, right? Okay, so what do I do at this point?
Subtract 3.
We're going to subtract 3. This cancels out. We have 0 or negative 0.6 is less than or equal to what?
12.
Oh, I've got my x. 12. Okay, now what do we do?
Divide by 0.6.
Divide by what?
Negative.
Negative, and you said the key word, right? Negative. You're dividing by a negative. That means we flip our sign. Okay, and what is 12 divided by negative 0.6?
Negative 20.
Negative 20. Okay, my variable's on the left, so we're good. So how do you graph that? You have a 0, you have a negative 20. Open circle or closed circle? Closed. And do you graph to the right or to the left? To the right. All right, now I'm going to show you the check step, okay? Now, the reason I'm showing you the check step is I want you to understand or fully understand when you have an inequality what the solution set actually is. What are the solutions to this problem? Because like an equation, you have x is 3. It has to be that number, whatever you solve for, correct?
Yes.
An inequality has a range of numbers, and I want you to understand why that is. So let's do this check. So let's say that x equals 0. I can actually pick out any single number I want that is greater than or equal to negative 20. And no matter what number I put in there, if I put in 5,864,
It's always going to be true.
it will always be true, okay? So I'm going to show you what we're talking about. So if we fill this in, negative 0.6, x minus 5, less than or equal to 15. I decided, since this line goes over that 0, I'm going to fill it in, okay? So I'm going to pull out the x, and I'm going to plug in a 0. All right, so negative 0.6, and this is 0 minus 5. It's less than or equal to 15. Order of operations says, what do I do first? Parentheses, okay? I have to do parentheses. I'm not going to distribute because I have two numbers in a parenthesis that I can simplify, correct?
Yes.
So that's the difference in distributing and doing order of operations is I can actually simplify this. You distribute if you can't simplify the parentheses, okay? Are we clear on that?
Yes, ma'am.
Okay?
Is it 0.6 times negative 5?
Yes. Negative 0.6 times negative 5 is less than or equal to 15. Now what do I do? Multiply. What's negative 0.6 times negative 5? 3. 3 is less than or equal to 15. Is that a true statement?
Yes.
Yes, this is true. So what you're saying, when you're actually graphing an inequality, what you're telling me is no matter which number on this one, including negative 20, I can put in negative 20 or any number greater than that, and my inequality will always, always be true. Could I put in 10 and it be true?
Yes.
Yes, because x would be greater than or equal to negative 20. That's what the solutions, that's what they actually mean when you're talking about an inequality. So when I'm saying all my x values are greater than or equal to negative 20, what I'm saying is any x values or every x value I choose has to be greater than or equal to negative 20. Does that help you understand inequalities a touch better?
Yes.
All right, so now let's do number 3. Example 3. Now these are going to be our special cases. I'm going to show you two special cases here. And I think I called them special inequalities a second ago. Special inequalities. We have two types. What we're going to do is we're going to solve them, and then I'm going to tell you what they actually are. All right? So number 3. 14x plus 5 is less than 7, 2x minus 3, close parentheses. Okay. So I have to ask myself this series of questions. Okay, I'll give you a second to write that down. What's the first question we always ask? Can you distribute on the left? Can I distribute on the left?
No.
Okay, then what's the next question? Can I distribute on the right?
Yes, you can.
Yes, all right, so here we go. Let's rewrite this. 14x plus 5 is less than, what are we distributing?
7.
The 7. We're distributing the 7 to each one, okay? So that gives me, what's 7 times 2x?
14x.
14x. What's 7 times negative 3?
Negative 21.
Negative 21. All right. Do y'all remember when I was teaching you multi-step equations, I said Once you distribute on the left, distribute on the right, combine like terms on the left. Oh, let's do that. Can we combine like terms on the left?
No.
Can we combine like terms on the right? No. So at this point, now we have to combine like terms on the opposite side, correct? Are y'all with me?
Yes.
Okay. And I always told you, move your variable term first, correct? Now, if you do not move your variable term, you're still going to get the exact same answer. You are just going to do a whole lot more work than I'm going to do, okay? If you move your variable term first, you will find the answer quickly when it's one of these problems, okay? So if you get in the habit, once you've distributed and combined like terms, move that variable term. Let me show you why. So right here, if I move the variable term, I have to do what? Subtract. So I'm going to subtract 14x, subtract 14x. Well, doesn't 14 minus 14 give me a 0?
Yes.
And what is 0 times x? 0. Okay, so this is nothing. I can bring down my 5, bring down my sign. This is nothing, minus 21. Right?
Yes.
Okay, is 5 less than negative 21?
No.
No, it's not. So this is a false statement, correct? So when my variables are gone, if you move your variable and it's gone, and you have a false statement, because this is false, you have no solution. No matter what number you put in there, this is not going to become a true statement. No solution. 5 is not less than negative 21. It is false. Therefore, your answer that you would actually write down is no solution. Okay? A false inequality with no variables. Are you with me? Okay? So let's look at number 4. 1 minus 8m is less than or equal to negative 4 2m minus 1.
Is this another special inequality?
It is. It's my last special inequality. Okay, can I distribute on the left?
No.
Can I distribute on the right?
Yes.
Yes, because there's those parentheses. All right, so we have 1 minus 8m is less than, okay, negative 4 times 2m is? Negative 4 times negative 1 is? Positive 4. Oh, thank you. I forgot the equal to sign right there. The less than or equal to. Thank you. Okay. Can I combine like terms on the left? Can I combine like terms on the right? No. So now what do I have to do? Combine like terms on the opposite side, okay? So we are going to add 8m, add 8m. All right. This cancels out and that canceled out, doesn't it?
Yes.
So I have 1 is less than or equal to 4. Is that true?
Yes.
Is 1 less than or equal to 4?
Yes.
Yes, 1 smaller than 4, correct? All right. So this is a true statement. Okay? So your answer is actually all real numbers or infinite solutions. You can put either one. All real numbers are infinite solutions, okay? Because this inequality is true, no matter which number, any number on the number line, decimals, fractions, percents, positives, negatives, anything you come up with, no matter what you do, it will still be a true inequality. So then how do you graph that? Just like this. You put a 0 in the center, and you simply say all real numbers. You have a line with arrows going on both sides. All real numbers. Can you? Okay, what's your question?
What if you have, what for the no solution one, do you just put nothing on a number line?
Well, no solution. You don't have a number line because it's false.
Okay.
It's false, so I can't graph it. Good question. All right. So here, let's write a little summary of what we just did. When the value, well, sorry, not value. When the variable zeroes out, the answer is no solution when it's false, and all real numbers, or we can write infinite solutions when true. Oh, I have mine in the paper, so I'll have to wait. When the variable zeroes out, the answer is no solution when false, or all real numbers when true. I'm going to write infinite on this one. Because you can also say that it is infinite solutions. We'll work on this in class tomorrow.